Shafts or axles are part of the robot that spin and hold things like wheels, sprockets, and pulleys in position as they rotate. They're made of a variety of materials and come in different sizes and shapes. The material and size of the shaft are determined by how it is loaded. In years past, the most common type of axle we used as a team was round. The challenge with round shafting is locking the part to the shaft. We've tried things like drilling a hole through and using a bolt to pin it, but it doesn't always work that well. Another way to do it is using keyed stock. It has a groove where you can insert a steel key that prevents the part from spinning independently. Variations in keys and small damage to the shaft make getting the round shaft through bearings extremely difficult. We've got piles of old mechanisms around the shop with marred shafts that we can't separate the parts except by beating them with a hammer. In recent years, we've moved almost entirely to hex shafting. The most common sizes we use are 3/8 and a ½ inch. 3/8 shafting is very light duty, it's easy to bend or break, so we only use it on things that won't see much abuse or load. ½ inch is by far the more commonly used size, and it does come in both aluminum and steel, which is great if you need added strength in your design. You can always use other round or roundish things as axles. Just remember, anything that is off center or not perfectly aligned will get pretty violent if you start spinning them up at high speed. Things like PVC or wood are fine for low speed applications like intakes though. The last thing we'll cover in this video is how to keep the parts from moving around or falling off the end of the shaft. A common way to do this is using a shaft collar. They also come in various sizes, shapes, and materials, and there's a couple different styles. One style has a set screw that tightens down on the shaft. These ones are dead to us. They make dents in the metal which make the axle impossible to pass through the bearing, so we can't get it out of the robot. If you see one of these, throw it away. The second and most common one is the single bolt clamping shaft collar. When you tighten the bolt, it squeezes the collar onto the shaft. Depending on how much side loading force you have, these can be a great option. Smaller collars like these won't have much holding force, but a properly tightened larger one is enough to handle most of what we do in FRC. The last kind you'll see in our bin is a 2-bolt, 2-part clamping shaft collar. These are a bit more expensive because of the extra machining and hardware, and they only need to be used in high-speed applications such as shooters. Because they have symmetrical bolts, they're better balanced and will vibrate less at high speeds. Shaft collars will also work anywhere on the shaft. Other options include E-clips and spring clips. We've used spring clips in the past, and they're a real pain to work with. They require a special pair of pliers to put on and take off and shoot across the room when you remove them. We end up losing most of them. E-clips are a bit better as they can be pushed on and removed with a flathead screwdriver. Either one of these options requires a groove in the shaft. Creating grooves in the shaft can weaken that area, and we've had axles break at the weak spot. If it is a heavily loaded axle, you'll want to avoid putting any grooves in it, so stick with shaft collars to be on the safe side. Finally, the last and most used retention style is a bolt and washer on the end of an axle. We drill a hole and tap the end so the bolt threads right on there. It's cheap, fairly lightweight, and pretty easy to do. The only drawback to this approach is that parts that need to be held in the middle of the shaft can't be held on that way. You can use spacers on each side to prevent it from moving though, and that's something we do pretty often. Anyways, I hope this helps explain the kinds of axles and shafts we use and how we hold stuff onto them. If you have other ideas on the subject, drop me a line. We're always interested in seeing different ways of doing things. See you in the next video.